This is a solubility problem. We're mixing aqueous solutions together and asked to determine whether or not a precipitate is going to form. So first let's consider the ions that are going to be present in the final beaker to see if there's going to be a possible insoluble precipitate that forms. The one solution is 0.100 liters of 0.30 molar calcium nitrate. Excuse me. So we have calcium 2+, nitrate ions in solution, and here we have 0.060 molar sodium fluoride, and that's 200 milliliters or 0.2 liters. So our final volume is 0.300 liters. Our second beaker has sodium ions and fluoride ions. So if we consider possible ions, or excuse me, the possible compounds that could be formed, we'll consider all possible combinations. Calcium fluoride is insoluble. So depending upon its IP, it may or may not precipitate. Let's look at the other. Calcium nitrate, of course, is soluble. Sodium fluoride and sodium nitrate are both soluble, as all sodium compounds are soluble. Alright, so what we need to do is to calculate the new concentration of calcium and fluoride ions, because when we put them in add the two solutions together, the volume is changed, so there's going to be a dilution involved in the concentration of both these ions. So we need to calculate the new concentration of calcium 2+ and fluoride ion, and then calculate KSP. Excuse me, we don't know if we're at equilibrium, so we're going to be calculating IP. We'll calculate IP and compare to KSP. Alright, so if we look at our insoluble compound, calcium fluoride as a solid is going to exist in equilibrium with calcium 2+ and 2 fluoride ions. Our ion product, because again we don't know if we are at equilibrium, is going to be calcium 2+ times fluoride ion squared. Now we're not going to use an ICE table because we are given means to calculate our concentration of the different ions. So for calcium 2+, new, we need to find the moles in the initial solution. So we have 0.30 moles per liter of calcium 2+ in this solution, and we have 0.1 liters, so we have we can calculate our new concentration. We do a separate calculation. Our new volume is our 300 milliliters or 0.300 liters. So these two together give the number of moles of calcium 2+. We divide by our new volume, and our new volume of calcium 2+ is 0.100. For fluoride ion, same process, only here we have a different concentration and volume. Moles per liter, because every mole of sodium fluoride gives us 1 mole of sodium ions. And we have 200 milliliters to start, 300 milliliters at the end, and so our new concentration is 0.40. Alright, so we can calculate our IP. is calcium 2 plus concentration times fluoride ion squared. Oops, without my zero. And our ion product is 1.6 times 10 to the minus 4. KSP, we were given, is very small, 3.2 times 10 to the minus 11. So, since the IP is greater than KSP for calcium fluoride will precipitate. A reminder that as the solid precipitates, calcium 2 plus and fluoride ion are removed from solution. And that means their concentrations are both going to decrease. And that process will continue, more solid being formed, the concentration of these ions decreasing. And that'll continue until we finally have the situation where IP is equal to KSP. Okay, the concentrations will be going down, they'll be getting smaller, and so IP is getting smaller. Eventually we'll reach a point where IP is equal to KSP, at which point the solid will stop precipitating.